Okay, so well, this is about spatial knowledge graphs. So let me see. So what is a knowledge graph? So maybe there's some people in the audience that are still not really familiar with that. So my approach is there are different views, of course, and my approach is relatively simple. And I'm using this 5-star open data model that most of you probably do know for it. So normally when you start with linked data, you end up with publishing a 4-star linked data. So at least we did so because you transform your existing data sets to a linked data set. I'm also trying to share my camera, and I'm very bad in multitasking, but now it should work. We have this 4-star data, and I think with adding the 5th star, we're already building the knowledge graph. With adding the links between the data sets, we create our first version actually of a knowledge graph. And that's also when you really unlock the potential of linked data, because now you can query, you can analyze the whole set of data sets, the whole knowledge graph in an integrated way. So, so for me, 5-star linked data is already a kind of knowledge graph. Unfortunately, while publishing 4-star linked data is relatively easy, it's more or less a transformation of your existing data set in a different syntax, more or less. But the 5th star, it's getting more complicated in a way because you have to add more knowledge and that you didn't previously publish. So, and that's basically a bigger issue. It also leads to quality problems, but because you cannot really have a one-to-one relationship between everything. It leads to governance problems. Who's the owner of the link set? It leads to usage problems. You're not really sure what the user really wants. But nevertheless, the knowledge graphs are, in my opinion, the kind of data dream that you all have. And hopefully in this session, we're going to dive and learn a little more about these knowledge graphs. So, so let's see. So the first part will be about knowledge graph, and the second part will be about linked data tooling. So I really have to speed up, and I'm going to talk faster and faster. So because I have to give the floor to Elena Alvarado, and I probably do this pronunciation very wrong. Sorry for that. And she's going to talk about the project in Spain about applying the knowledge graph and semantic web technology over there. So, Elena, are you there? And I hope you are. I have to find you.
Hello. Yes. Hello, Ruin. I'm here. Hello to everyone.
Yes, great. And make you presenter. So if everything is all right, you can share your screen and your camera.
Okay. Sí, que no me va para allá. Se ve esto. Sorry. Okay. Okay.
Is it also possible for you to share your camera?
Oh, yes, please. Yes, of course. No, but sorry, because I'm with two... No, pero no me está compartiendo las notas.
No. Sí, minimiza esto y lo tiro detrás.
No me avanza nada. No. Okay, sorry. I wanted to do something, but it doesn't work. Sorry. Okay. Okay. My name is Elena Alvarado. I'm the CTO of GNOSS. I'm happy to be here in this.
Sorry to interrupt you, Elena, but now your screen is also gone.
Ah, sorry. I'm not presenting. Sorry.
Yes, it's there.
Yes. Okay. My name is Elena Alvarado. I'm the CTO of GNOSS. I'm here. I'm very happy to share with you this great. I'm happy to be here in this great event for spatial data and having the opportunity of sharing with you our experience in the exciting project of building the knowledge graph of the Geographical Institute of Spain. Sorry, because I have problems with my computer. Okay. I want to introduce my company very quickly. We are a technological small enterprise that has been working for more than 15 years in the construction of knowledge graphs and the web of data, who collaborates with organizations in transforming human intelligence into technological intelligence, and that have the aim of facilitating people access to a happier digital life. Okay, this is our main contribution in the linked open data cloud. In February 2010, GNOSS data was linked to Freebase, the Wikipedia, and New York Times, making the concept of linked data a reality. In September 2011, GNOSS was the first company to appear on the linked open data cloud, an essential part of the conception of the semantic web. And in November 2019, GNOSS becomes a member of the Wikipedia Association, and we are very happy for that. And our main product is GNOSS Knowledge Graph Builder. It's a semantic framework for developers, and it is the software that we have used to build IGN Spain geographical graph, knowledge graph. The main functions are metadata management and knowledge graph construction, discovery reason analysis through knowledge graphs, and semantic content management. Okay, let's start with the project. The main objectives of the project have been to semantically represent the wide set of geographical resources of IGN Spain, to link them and to publish them in a unified knowledge graph that can be interrogated by machines and by people. These are the main ideas. We have built a unified knowledge graph, and this graph is interrogated by machines and by people, very important. Also, to build a single interrogation point for people, that is a meta search, a unique search engine, a unique single point to search for all this knowledge. And also to offer intuitive interfaces for users that can allow them discover the rich heritage of the institution. Okay, this diagram expressed in a very conceptual, high-level, very high-level idea, which are the main purposes of the project and what we have done. Okay, we have integrated the knowledge of these three structured data sources of IGN Spain that at the beginning of the project that weren't connected. Okay, these sources are geofiles, more than 2 million files, map library, where they have bibliographical resources that with metadata that describes these geofiles, and the virtual store, where they'll sell geographical products. Okay, all this data is integrated in a unified knowledge graph and stored in a RDF store. We also define a digital semantic model to represent all this knowledge, and we also create algorithms to enrich, group, and link entities. Okay, all this data were linked through these algorithms. The result of, and also we build the AGN Spain semantic web that includes interrogation systems based on human reasoning, meta search and specific search engines, also geographic search systems that you can draw a polygon and look for maps in this area, enriched web pages for every geographical product, and also context information for every content. Okay, this is the high-level semantic model. We have more than 50 classes in this model. These are the main entities: geographical resource, bibliographical resource, product distribution, feature, user, subject. Okay, We have used reference models to build this knowledge graph. The main reference models we used was Inspire Metadata Regulations Mark 21, GeoNames Ontology, SCOSS, and Schema. Okay, the projects in numbers. As a result of this project, we have 2 million geographical resources semantically represented. We have also 16 graphs in the RDF store that includes more than 150 million triples in total. Okay, let's see IGN Spain Knowledge Graph in action. Okay, I'm going to show you how the system works. Okay, I can look for some place, for example, Logroño, which is our city where we live. Okay, I look for Logroño, and as you can see, we have here the geometry of this municipality. We have here the results of this search, and we can also search by categories and scale. We can filter the results, okay? Also by authors and by a period, okay? I can also, for example, look for the geometry of one of these results. For example, this one. I click here, and I can see where is the geometry and how it intersects with the first search and this other, for example, and this other. Okay. I'm going to show you another kind of search. I can, for example, draw a polygon. I'm going to Madrid. Here, I can draw a polygon because I'm looking for maps in the north of Madrid. Okay, the system gives me the geographical results in this area. Here you are. I can filter them as in the previous search, and I can also click in one to see if this is the area that I want. No, I don't want this area. I prefer this one. Okay, I'm going to the enrich page of this geographical resource. Here we are. This is enrich page with a visualizer. Okay, I can look into and zoom out, zoom in, zoom out, and I can show the specific information of the resource. We have here all the printed editions of this map, okay? They are all of them organized by year. Here we are the format. We can download it, add to a personal list, and also buy it because it's in the virtual store. But now we have here on a single click. Here we add the information. I can buy it. I can also get here with a single scroll this map in vectorial format or in raster format, organized always by format and by year. Okay. Again, information.
Sorry, Elena, to interrupt, but I think you have 1 or 2 minutes maximum left. So please, can you wrap up?
Okay. Sorry, very quickly.
No
I'm going back to the presentation to close. Okay. Okay. Sorry, I have to. Okay. Let's. I want very quickly to tell you the challenges for us in this project. The main challenges have been defining and building the sort algorithm based on weight. It's very important that the more relevant results were in the first page of the result set. Improving search engine performance. We have 2 million resources described very expressively and very complex queries that we have to improve. Building group geographical resources, recognizing the geometries of every single file and group them has been a very hard process. Identifying all distributions, geofiles with similar geometry and same category on neighboring categories, the same thing but more specified. Denormalizing geographical data. To improve the searches, we have also to simplify the points of geometries and grouping them. And also adding some natural language processing. We have convert textual searches into geographical searches thanks to toponym recognition, and also converting textual searches to entity searches also, thanks to category recognition. And that's all. Thank you very much. And sorry for taking more time.
Oh, no, thank you, Elena, very much for your talk. It's very interesting. And I think as organizers, we have already one lesson learned that 10 minutes is relatively short also with the technical stuff, with changing over. So maybe that's something we should improve for next time. But really, thank you for your talk, Elena. There are some questions from Elwin and Benedicta on the chat. So and I don't think we have time for it right now, so hopefully you can answer them during the chat so that we can move on now to the next speaker. So again, thank you, Elena. We move on to Mehdi Zrhal. And again, this is probably a very bad pronunciation, so hopefully you can do a better job, Mehdi. And go ahead with the talk about data search and knowledge graphs.
Okay. Here we go. I'm just gonna. Okay. Here we go. Can you see my screen?
Yes. If it's possible,
Okay.
you can also share your camera.
Oh, yeah. So, okay, just 1 second. I have a problem for sharing my camera.
Camera. The slides is more important, but
Okay.
But currently the
So,
slides are also gone. So.
So I don't have the access of don't have the access to share my camera. So go to my slides. So
can you share your screen
again? Yes, I will do it just right now. Okay.
Yeah.
I think you can see my screen.
Yes.
Okay, so hello everyone. My name is Mehdi Zrhal and I am a PhD student. And today I'll be talking about search and knowledge graphs. There are models that are published and that are available online. And the big portion of these datasets are spatial datasets. And one popular way to find the spatial datasets is to search on geographic catalogs. These catalogs store metadata about the datasets that are provided by the owners of these datasets. As you can see here in this slide, metadata is structured data about datasets that can be then used to retrieve datasets on catalogs. There exists a lot of catalogs on the web, and each of them has its own specificities. These are 3 of them. There are 3 French catalogs. Let's say, for example, that I'm looking for a dataset about La Seine River in France. So first, I need to find the right catalog to use. Is it the Inspire catalog, the Inspire dataset specialized catalog, or maybe the one who is specialized in hydrographic datasets, or the one who is specialized in public government data, which can be very difficult for a user who doesn't know which catalogs exist, and it's not very practical to find datasets this way. But first, let's take a look on how these catalogs manage to find datasets that he has indexed. So most of them use information retrieval algorithms. The problem is that there is no relevance model that is dedicated to these datasets or spatial datasets. Therefore, most of search engines use plain text search over the name and the description fields of metadata, and sometimes they use some facet search also. And the query is considered as a text that has to be matched with metadata, which makes dataset search on catalogs not very efficient. And one solution is to use metadata that are represented as linked data, and that is what was done by Google Dataset Search and European Data Portal. So let's take a look on European Data Portal. What they have done is that they harvest metadata from 81 different catalogs and from 36 different countries, which allows them to index more than 1.1 million datasets, which resolves the problem that I have given an example for when I was talking about catalogs. So to do so, they transform the collected metadata into linked data using the DCAT AP vocabulary. This allows them to use the Sparkle query search, which can be very efficient if the user knows how to write Sparkle queries. But most of regular users cannot do that. And there is also the Google Dataset Search, which crawls the internet to index metadata from various sources. As long as schema.org or DCAT vocabularies are used to describe these metadata. It's not specific for spatial datasets. And once metadata is indexed, the dataset search engine uses the same principles as the classic search engine, including Google's knowledge graph. But the problem is that Google Dataset Search is not very efficient when it comes to spatial datasets. It has difficulties to find this kind of datasets. This is an example that I given here. In this query, I was trying to find dataset of France's road network as it was in 2015. Most of the first ranked results are statistics about the road network in France and not actual spatial data. The first spatial dataset that has returned, it's the fourth. It is the fourth result, and it's a dataset of the road network of France in the 18th century. So with all these problems, we are proposing a framework for spatial dataset search engine that we will be using. Links metadata units, and our main idea is to consider the user's query and the metadata as sets of concepts that we can compare to each other. So first, to index metadata as linked data, like what it was done in European Data Portal, which allows us to gather metadata from different sources, and on top of that, we want to identify the concepts used in the metadata and align them with the knowledge graph, for example, Wikipedia. Then we allow the user to express its query as a set of concepts of interests that are included in the knowledge graph we use. The query is then formalized, extended, and refined.
Sorry, Mehdi, to
An
interrupt.
example of what. Okay.
Sorry to interrupt you, Mehdi, but also for you.
Okay, I will just finish rapidly, quickly. So yeah, we then want to formalize, extend, and refine the query. Then we will select the result from the indexed metadata. As if sometimes we don't find at any data set, we will extend more the query of the user. Then we will rank this result using a relevance model that we want to develop, and this relevance model we want to develop is not meant to be generic but only specific for a use case. And then we want to present the results for the user, and I think that's it. So thank you for your attention, and if you have any questions.
Okay, thank you, Mehdi, for your talk. Interesting topic, I guess. We all want to have our data sets better found, and I think this can be a solution for that. But isn't it, maybe a short question, isn't it not the first step that we as countries publish our metadata in a better way, in including RDF, schema.org annotations, etc.? So because you...
Sorry, I didn't hear. Can you please repeat?
Is it not a starting point that we as countries have to better publish our metadata in RDF format, including schema.org annotations, etc., so we're able to be part of the knowledge graph?
Oh yeah, of course. This is I think this is one of the first steps to take. One of the problems that I have to try and develop a prototype of my idea is to find a good metadata that is described as linked data. So yeah, it's a very important point to start with. Yeah.
Okay. Well, thank you, Mehdi. I see there are some questions in the chat for you as well, so please answer them in the chat, and thank you for now.